So have out your books, your homework. Be ready to help me. I'll get this picture drawn for 11 or 12 through 16. We're actually going to do all of them. I'm going to go around the room, have you read, so I don't have to keep my book open. So have your book out. The other thing I want to say, let's get rid of that. The other thing I want to say is, next class, make sure next class you have your laptops. We will be using them. And make sure next class that you have a calculator. No ifs, ands, buts. Does that look like I drew everything that's supposed to be on that picture? I didn't miss anything, did I?
Right.
Thank you. All right, Chloe, read number, I know we didn't do number 11, but read number 11 to us.
Name two acute vertical angles.
Two acute vertical angles. Somebody give me a letter where there's going to be vertical angles. What should you look for when you're looking for vertical angles?
Something less than 90 and more.
Just vertical angles.
Oh, vertical. Oh, from the I was doing
Look,
vertical.
two lines that intersect this way, right? So give me a letter.
Oh, I see it now.
U. That's a good one. Give me another letter that maybe would work.
T.
T. The only bad thing with T is, name this angle right here for me.
No name.
You can't name it, can you? Because there's no letter out here. So we're probably going to have to use this one. So on number 11, name me the two angles that are acute vertical angles.
BUW and YUX.
Are those acute?
That's for number 12.
That's for you're looking for.
Oh,
I'm on number 11. Acute. So keep that thought in mind here in a minute. Anybody?
WUY.
WY, that's this angle. Everybody agree with that? Does that look acute? So angle WUY and say it again. Are those two vertical? Katie, I'm not going to have to move you today, am I?
Maybe not.
I think I'm going to right now.
Okay. I'll move over.
Move you way back here in the back all by yourself.
I'll probably end up talking in a second.
That's all right. At least I won't be able to hear you. Number 12. Olivia B, read number 12 to us.
Name two obtuse vertical angles.
Now, Chloe.
BUW and YUX.
So angle VUW and angle YUX. Now some of these, like an angle like YUX, is there another way you could have named that angle? XUY, that'd work? Give me another way. How about this?
Oh, good. That's what I had.
Could you have stopped at T there instead of going on out to Y? Yeah, it doesn't matter which is the only letter that really matters in an angle. The vertex. All right. So the vertex. So you could have named this XUT. You could have named it XUY. It still means the same angle. Number 13. Katie, read number 13 to us.
There's a pair of, I don't even want to try it, complementary, I always say tree, complementary.
That's fine.
Adjacent angles.
Complementary adjacent angles. What's adjacent mean again? Anybody?
They
They share a side, share the same vertex, so they're hooked together. What's complementary mean?
Equal 90
They,
together.
they add up to 90 together. So does anybody see a pair in this picture?
Oh yeah, the U, W, and Y.
UWY, is that one we'll write down?
What would it be? U, W, T, and U, or I mean then T, W, Y.
Alright, so Katie's saying that she knows that this angle right here is a right angle. So these two angles together have to add up to be how much? 90, so they're complementary. So name them one more time for me, Katie.
U, W, T, and then T, W, U. I mean Y. T, W, Y.
Everybody agree with that? So UWT, TWY, are those two complementary angles? Are they adjacent to each other? Yeah. 14. Sarah Ray, what's 14 say?
14. Is that weird? Name a pair of complementary non-adjacent angles.
So same idea, but this time we don't want them to be hooked together. What would those two be? Say it. Shh. Say it one more time. VUX. Close. VXU. This angle, what do you know about that angle? It's a cube, but what, we know more than that. 60 degrees. Say it one more time. What do you guys gotta remember when you're naming angles?
The vertex is in the center.
Vertex,
And the two numbers.
vertex has to be in the middle. Where's the vertex? I think all you guys are trying to name the correct angle. Where's the vertex at on that angle? Y. So how would we name it? That's why we're doing this. Hopefully, if you're naming something wrong, just mixing up the letter or something, we get that out of the way now before we get deeper into the year. Number 15. Charisse, read number 15 for us.
Name a linear pair whose vertex is T.
T. Let me do this. Can't see that anymore. So we want our vertex to be right there. What's a linear pair, anybody? Don't make linear pairs harder than they are. Think of what the name says, linear pair. So what's pair tell us? Two angles that form a line. Two angles that together make a line, linear
Wait,
pair.
Isn't it another name for the supplement?
Sort of, yeah.
Whereas trade-
So supplementary angles. Alright, so name me a linear pair right there. Just pick an angle right there. Name any angle right there that has vertex of T. WTY. You can't be wrong with the first one. WTY. That's this angle. WTY. Now we want another angle along with that angle that together form a line or a straight angle.
Does it have to have T as the, okay, well then, yeah.
WTU. Now together, did they form a line?
Uh-huh.
Yeah. And where some of you were probably having trouble there, do these two angles, can't get my pen to work anymore. These two angles form a line? Could we have used those two?
Yeah.
Yeah, except what couldn't we do on this angle over here?
Couldn't put it.
We couldn't put a letter, couldn't name it, right? So we had to name those two. Number 16. Read number 16 for us, Ariel.
16. Name an angle supplementary to angle UYZ.
UYZ. Sure. Read it again.
Name an angle supplementary to angle UVZ.
That sounds better.
I about said Y for V that time.
UVZ, that's this angle right here.
Man, not that bright.
Now, could they have asked us the same question that 15 asked us? And said name a linear pair with that angle? Yeah, it's still been the same answer. Name an angle that's supplementary to this angle right here.
UVX?
So UVX, Katie saying this angle?
Yeah.
Everybody agree those two have to add up to 180? Is that right?
Wait, are you asking do they have to or do they?
Either way, if they have to or do they, it should be the same answer.
I'm very confused.
So do these two add
I'm
up?
sticking with my answer.
Do they add up to 180? Yeah.
Could you use W, Y, U?
Do we know for sure that, well, give me 1 second. Let me write this down, then I'll explain that. Angle UVX is the actual answer. Now, Olivia's asking, WYU, that's this angle, right? This angle and this angle sort of look like, hey, they make up this line, but do they share the same vertex? Right? And if they don't share the same, if I do something like this, see how we have this line along the bottom? Does that mean that these two angles right here have to add up to 180? No, but if I do this, we still have the line across the bottom. Do these two angles have to add up to 180?
Yes.
Because they share that same vertex. That makes sense, Olivia? So out here on the ends of a line doesn't really help us. Together with the same vertex would help us. So it has to be angle UVX. Next problem. Where did we jump to next? 17. We didn't do 17 though, right?
No, we didn't do any on.
Yeah, we did 18, right?
No, it's
Problem 18, let's jump to that. We'll do 18 and 20 and 22, and we'll jump on down. Problem 18. So now I'm grabbing my book here. Kelsey, read problem 18 for us.
Measure of two complementary angles are 16z minus 9 and 14z plus 3. Find the measures of the angles.
All right, now, Kelsey, you get a bad job, and a couple of the rest of you too, because once we've read the problem, I'm pretty slow, all right? So once we've read the problem, now we got to go back through it and read it slowly, one part at a time, so Mr. Eversole can understand it, all right? Now, the first thing, before she starts reading again, we're going to do a lot of problems that are written this way. Talks about complementary angles, supplementary angles, whatever they talk about, vertical angles. I'm going to tell you that 99% of the time, this is how I want you to start every one of these problems, because it's going to make it a little easier on you. How many angles are we going to be dealing with? 2. So normally, this is what I want you to do. Angle 1, angle 2. When we're doing one of these word problems that deals with angles, start off every one of the problems, angle 1, angle 2. Probably did some problems like that in algebra, right? Where you had the first number and the second number. I don't know how Mr. Harrison or Mr. Griffin explains them, but you probably had the first number is twice as big as the second number or something. They said one number is twice as big as another number, and you had to set up an equation to solve them. Same idea here, but I start every one of my problems out this way if it's this kind of problem. Angle 1, angle 2. Go ahead, Kelsey, read a little bit.
Measures of two complementary angles.
All right, stop right there. Complementary, what's that tell us? Anybody? 90 degrees. Someone write that up here, because I'll forget it if I don't write it down.
Are 16z minus 9.
You can read that well enough, right?
16z equals 9.
That's fine.
Minus 9.
Go on.
and 4z plus 3.
Plus 3. Find the two angles, right? Once I have it set up that way, can I set up my equation now? Yeah, and Sophie's looking at it saying, Mr. Ursel, you're an idiot because why do you have to write all that down? Maybe you don't, all right? But if you're getting confused, this is the way I would do it. I have to do it this way. What equation can I set up?
16z minus 9 plus z plus 3 equals 90.
This plus this should equal
90.
90 because they were complementary. Collect like terms, what do we get? 20z minus 6 equals 90, good.
And then you add 6 to each side, 96, and then you divide it by 20, 96 divided by 20 equals a number that I don't know in my calculator.
So
4.9.
make sure you got your calculators out because we're going to need them for some problems the rest of the time. So is that our answer, 4.8?
No, you have to plug it back in to 16.
They want the two angles now. Katie's getting ready to plug into the 16z minus 9. If it was me, you think I'd plug in there?
No, you do the little one.
Do the smaller one. So 4 times 4.8 plus 3. Somebody do that for us real quick. Tell us that answer.
42.2.
Yep, she's got it.
22.2 degrees, good. Now, once we know that, do we have to plug into the 16z minus 9? What might be an easier way? What'd you know about the two angles originally? They're complementary, good.
I would just subtract 22 minus 9.
So just take, you got it right there on your calculators, take 90 minus 22.2, and what do you get? 67.8. That's probably a little easier than plugging it into that, right? Number 20. Number 20 is the same kind of problem, right? Sophie, read number 20 to us.
The measure of an angle supplement is 44 less than the measure of the angle. Find the measure of the angle and its supplement.
All right. Same kind of problem, so I'm going to start it off this way. Angle 1 equals angle 2 equals. We know we have two angles. We're going to start it off that way. Now Sophie's got to go back and read it slow for me so I can get it all, soak it all in again.
The measure of the angle supplement is
All right, stop right there. Supplement, what's that tell us?
180.
So I'm going to write that down up here so I don't forget it.
is 44 less than the measure of the angle.
All right, so the angle, what are we going to let the angle be? Do we know it?
No.
So what do you let it be if you don't know it?
Equal 1.
What do you let it equal?
40 less my negative.
That's the
40.
other angle.
Okay, 180. 90.
Say it, Kelsey. We don't know it, so anytime you don't know something, what do you put in there?
A variable.
A variable. So we're going to let angle 1 be x. Now Sophie's going to read that second part to us that it explains what the other angle is again.
Find the measure of the angle and its supplement.
Go back.
The measure of the angle supplement is 44 less than the measure of the angle.
44 less than the angle. Well, our angle is x. We want this one to be 44 less than that. How do I translate this? What's 44 tell us to write down? Nobody knows what 44 tells you write down mathematically? Let's tell you write down 7, 9, 12. You see 44, what do you write down? Thank you. Come on now. Less than. How do we translate less than?
Negative.
Minus. All right. What's our angle? Now the bad thing here is, and I use less than a lot in this class, so make sure you're listening real close right now. When you see less than, that's not correct, because if I say, what's 2 less than 5? What number is 2 less than 5? 3. What did you do there? You subtracted, but you didn't subtract 2 minus 5. What'd you do with the 2 and the 5? You switched them around. What do you got to do here with these two? Switch them around. Anytime you see less than, you got to switch those two terms. So now tell me what we're going to represent angle 2 as being. That makes sense. Ruth, that makes sense?
Yeah.
You sure? I use less than a lot. You got to remember what less than tells you to subtract, but it also tells you to turn the two things around, whatever you're subtracting. Now, what equation can we set up? After we went over all that, what did we know about these two angles?
They equal 180.
So tell me the equation we can set up.
X minus 44 plus
Just remember, you got to have two angles, right? That's one of your angles, that's the other angle. Those two angles together should add up to 180. Now what?
minus 44 from,
Before that.
plus 44,
Combine like terms, we get
2x. And then you come plus 44. What, 24? Or 224 maybe?
equals what?
Divided by 2x. And divided by 2. And then 1,
Is that our answer?
No.
Yeah.
That's part of our answer, isn't it, this time? That's the measure of angle 1 up here, 112. How do we find angle 2?
Plug it in.
Plug it in. You could plug it in this time. You could subtract from 180. What is 112 minus 44?
68.
So those are our two answers. The two angles are 112 and 68. Could we check our answer and make sure? What should they add up to be?
Together equal 180.
They should add up to be 180. Next one, what number we're on, 30?
Why do we do all like
Oh.
evens and odds if we just do evens? Like when we're reviewing.
For more practice.
We're not doing the even or the odds now. We haven't done the odds for like 3 problems now.
But we started off doing like,
Right, just because those were easy and might as well go through them all, right?
yes.
Which one are we on now?
22.
22? Somebody read 22, Sydney, read 22 to us, please.
The measure of angle 1 is 5 less than 4 times the measure of angle 2. If angle 1 and angle 2 form a linear pair, what are their measures?
Same idea, I'm gonna start off this way. Angle 1, angle 2, this time they actually told you angle 1 and angle 2, instead of us just doing it. Now Cindy's gonna read slow again for me, so I can understand everything.
The measure of angle 1 is 5 less than 4 times the measure of angle 2.
Alright, so this time, which angle are they sort of saying that we have to let be x? So we're gonna let angle 2 be x. Read that part to me one more time, Sydney.
The measure of angle 1 is 5 less than 4 times the measure of angle 2.
How am I gonna represent that? What's the 5 tell us to write down?
-5.
Yeah, sort of, we'll get that in a minute.
Minus 4.
Minus 4x, and then what do we do with these two? So tell me how to write that. Very good. Now, what they tell us about the two angles? Together they form a linear pair. If they form a linear pair, what's that tell you?
180, they equal 180.
They add up to 180, so let's hurry through this since you guys seem like you're getting bored with it. What? Tell me how to set up the equation.
4x minus 5 plus x equals 180.
Collect like terms, you get 5x minus 5 equals 180, add 5, you get 5x equals 185. Somebody help me out, what's 185 divided by 5?
37.
Is that our answer?
No.
It's one of them, right? That's this angle. How do we find the other angle? Probably easiest, just subtract it from 180. What do you get? Next one, 24, right? You just read that one. Sydney, did you read that one? You read the last one? Olivia W., read the next one to us.
If two angles are complementary, they are both acute angles.
Oh, these are different ones. Oh. Alright, on these problems, I thought it was the same kind of problem. On these problems, always, sometimes, and never problems. You'll see a lot of these throughout the year. They're asking you, is this statement always true? Is it sometimes true? Is it never true? And you just have to write always, sometimes, or never. So Olivia, one more time, read that to us.
If two angles are complementary, they are both acute angles.
So you got these two angles. And we know that together they add up to be how much? 90, because they're complementary. So they're saying if these two angles are complementary, if they add up to 90, then do they always have to be acute angles? Yes. How come?
Because if they're all twos, make it bigger.
Alright, so if one of them was 100, could it, with this other one, add up to be 90?
No, well, unless it's like a negative angle, but no.
And we haven't dealt with those, right? And we're not gonna deal with those, so if one of them, if they're complementary angles, then both of them have to be less than 90. Now, could one of them be 89?
Yeah, and then the other could be 1.
Alright, so that's alright.
Wait, and then you say the answer is always?
Always.
Oh, okay. Oh, I see, okay.
Because that always has to be true. That statement always has to be true. 26. Ruth, read 26 to us.
If line PN is perpendicular to line PQ, then angle NPQ is Q.
What might help us on this? Draw it. So if I draw PN, what's this symbol tell us? So what's that mean? Okay, they come together to form right angles. Where am I going to have to draw PQ? How am I going to draw it? Down the middle right here?
Well, not necessarily.
Why not? Look,
You have to draw it from
to where? Over to here?
Oh, wait,
Over there?
no, just straight down, maybe?
Why straight down?
I don't know.
Because what's this tell us?
I don't know.
It's got to be a right angle right there, right?
Yeah.
So that's our picture. Now, it said if that's true, then what was the other part? Ruth, what was the second part?
angle NPQ is a Q.
Angle NPQ is an acute angle. Is that going to be an acute angle?
No, because it's a red angle.
Is it ever going to be an acute angle?
No, because it's a red angle.
So our answer is
Nah.
no. Is 28 the same kind of problem?
No.
No, it's different. Is 28 the hard one? No, it's 30. Isn't it?
Your pen went a little black.
What's 28 say? Chloe, what's 28 say? Has it got a picture?
Yeah.
it is. Give me a second. Let me draw it and then I'll have you read it to us. On the homework tonight that you're gonna have, lots of problems like this one on the homework. I'm not even gonna draw the rest of it, let's just go with that. Read it to us.
It's the measure of angle AFB.
Stop right there. Somebody tell me where is angle AFB?
It's a little, first little, that one.
This
yeah.
one? Alright. Go on, Chloe.
Equals 8x minus 6. And the measure of BFC.
Is that this this angle?
Yep.
equals 14x plus 8.
Alright,
Find the value of x so that AFB is a right angle.
so this whole angle right here, they're saying is a right angle, right? So what equation can I set up from that information?
8x minus 6 plus 14x plus 8.
Does it matter which angle? Some of you wanted to start off with the 14x, some of you want to start off with the 8x. Does it make any difference?
No.
And that should equal what? 90. 22x. Is that a plus 8? Was that a plus 8? I was thinking it was a minus 8. Subtract 2. I think my first class told me wrong. I think they told me a minus 8 there. Now what?
It was minus 6, maybe that's what you were thinking. I don't know.
Because we got a different answer than this, because it didn't come out even. What'd they ask us to find?
X.
So do we have to plug that back in?
No.
No, that's our answer. It seems like first time around we got something like 4.8 or something like that different. Problem 30, that's the hard one, right? So watch carefully on problem 30. If you've not watched anything up till now, please make sure you're watching on this. Don't make me go back over to Mr. Harrison, tell him how poorly you guys remember everything that he taught you last year, all right? So problem 30. Olivia, start reading problem 30. Olivia B, start reading problem 30 for us.
Angle L and angle N are complementary.
All right, stop right there so we don't have to go through this one twice. They're complementary, so we know they add up to what? 90 area. You're going to remember that for us, right? They add up to what area?
90.
90. All right.
Angle N and angle P are complementary.
Angle N and angle P. I wrote them backwards, but they're complementary. So Kelsey, what's that mean again? So Kelsey, you're going to remember that those two are complementary, right? Ariel, what do you remember?
They're 90.
The first two add up to 90.
Am I allowed to sharpen my pencil?
Yep, go ahead. All right, go ahead, Olivia B.
If n angle L equals y minus 2.
Y minus 2. So measure of angle L is y minus, y minus 2. Right up there. Everybody knows that goes over there, right? Go on.
M and angle M
Measure of angle M.
equals 2x plus 3. Measure angle N equals 2x minus y. And measure of angle P equals x minus 1. Find the values of x, y, and measure of,
All four of the angles, right?
yeah.
So we're gonna find x, y, and we're gonna find the measure of each of these angles, so we should have 6 answers. Somebody give me one equation that we can set up to start to solve this. Ariel, what did we know about these first two angles?
They equal up to 90.
So what equation can I set up?
2x plus 3, and then y minus 2, and plus y minus 2 equals 90.
All right, just set peacefully for a second while I'm gonna simplify this all down. We got 2x plus y, positive 3 and a negative 2 give us a positive 1, that equals 90. I'm gonna subtract 1 on both sides. 2x plus y equals 89. What's wrong with that equation? It's got 2 different variables. Can't do anything else to it, right? So we stop there for a second. Let's try the other one. Kelsey, what'd they tell us about these two? They're complementary, right? So somebody help me set up another equation. Maybe this will come out a little better.
2x minus y plus x minus 1 equals 1.
Let's simplify this down. 2x and x give us 3x minus y minus 1 still equals 90. Add 1 to both sides. These cancel. 3x minus y equals 91.
Still two variables.
Well, that sucks. Now what do we do? Can you solve equations that have 2 variables in them? Yeah, you learned it last year, systems of equations. You learned 3 different ways to do it. One way was by graphing. These are all linear equations. So one way was by graphing. You graph these 2 lines, and what do you look for? See where they intersect at. That's the solution. Did most of you enjoy graphing?
No.
No, it was a lot of work, right?
Yeah.
Another way was substitution.
An elimination.
Substitution isn't too bad if one of the variables on the side by itself and you can just substitute in the other equation. This time we don't have that. And what's the third way, Sharice? Elimination, and that's probably the way that you like the most. Now to use elimination, notice I've already done it for us here. Both equations have to be in what form? Anybody remember that from last year? Starts with an S. ST. Not slope intercept, it's the other one.
Starts and
This was slope intercept form. Y equals mx plus b. That's slope intercept form. Are these equations in that form right now? No. This is called standard form.
I knew that.
All right,
I said that.
standard form. So we want them in standard form so we can do this. If I line them up over here. Does anybody remember how you do elimination?
You eliminate like positive.
That the y is gone now.
All right, you try to get rid of one of the variables, right?
You can get rid of y.
Sometimes you have to multiply either one equation or both equations by some number or numbers to get them to be opposites. In our case, this time, what do we notice about the y's?
Guys cancel out.
They're already opposites, so all we got to do is add straight down. What's 2x and 3x give us? What happens to the y's?
Cancel out.
Cancel out. What's 89 and 91 give us?
180.
What's nice about this new equation?
Divide by 5 down.
Divide it by 5 and solve. If you have a TI 84 or 83 calculator, I have a program on my calculator that if I get them in standard form, it'll do all the math for you. All right?
You have to show what?
Sometimes I'll probably say yes, sometimes no. So we divide by 5, what do we get? What's x?
36.
Are we finished?
No.
What do we got to do now?
Substitute.
All right, now we got to take that 36 and plug it in somewhere and find y. Maybe the easiest place right here. It doesn't matter. You can put it in here, here, any of those places. It's all going to give you the same answer. You want to find the one that's the easiest to do. So if I stick it in right here, somebody help me out. What's 3 times 36?
108.
Somebody just tell me what y is. Solve it. Finish solving it.
Nine, 13.
17. Everybody agree with that?
Yeah.
Is that our answer? Are we finished?
No.
We got 2 of the answers. We said at the beginning we're going to have 6 answers. We got to find the 4 angles. So if I go back up to angle L here, y minus 2 was angle L. So what's angle L?
15, or, yeah.
15 degrees. Here, what's angle M? 2 times 36 plus 3 gives you what?
70, or 69 maybe?
75.
I mean, yeah, I just put
You
down.
went the wrong way. You subtracted 3 instead of added.
And I just like really, oh,
So that's those 2 answers. N and P, which one's going to be easiest to find?
P.
P? What is P?
35.
You just subtract 1 from 36, right? Now, I don't want to plug in here because there's 2 variables and that's more work. What do you know about angle N and angle P again?
90.
So-
35,
35,
9.
What do you get?
5.
So Olivia W., remember all that from last year? I don't have to go back and tell Mr. Harrison.
Don't remember it all perfectly.
We're gonna do a lot of problems dealing with systems of equations throughout the year, and a lot of problems dealing with anybody remember what those problems were called? No, yes, maybe? Quadratic equations. We're going to do a lot of problems dealing with quadratic equations. Does anybody remember what you got to do when you're dealing with quadratic equations? The opposite of it.
Unfoil.
Factoring.
Oh.
Everybody loves factoring, right?
Yep.
I have another program on my calculator that'll solve quadratic equations. So maybe later on in the year we can download those. If you got a TI-83 or 84, we can download them to yours. What's your question?
Can you say where you should have done at?
Yeah, we should have been done a long time ago. You guys taking too long. Which one's next? I might even just skip the rest of these.
Yeah, that's fine.
I'm sick of doing them. 32. Were those two angles congruent or not?
Wait, which one?
32.
Yes.
AEB and angle DEC. How come they're congruent? What kind of angles are they? Starts with a V. They're vertical angles, so we know that they have to be congruent. 34. Angle DAE and angle ADE. Are those congruent? We don't know, do we? So no. What was next? 41. 41. Which statements in the figure is true? A. X has to be greater than Y. Can you figure out what X and Y both are? What's Y in that picture? 89. Because they're vertical angles, right? And what would X have to be? Not 89. What do you do with those two? You know that they have to add up to be how much? 91, right? 43. I'm not even going to talk about 43. They're just asking you, if I stick this on the board, can you say it's perpendicular to that plane? Could it form a right angle with the plane? Yeah. So could you put your pencil right there on your paper and make it form a right angle coming up out of your paper? Yeah. They just want you to be able to think three-dimensionally instead of, what was the next one? 50? Find the distance between, what do we got to use? Find the distance. Distance formula. And we're going to do some of that here in a second anyway, so I'm skipping that problem. Right? What I want you to do, these two papers, they go in your notes. So